And the last part of outcome 1 looked at the normal model. This should be quite easy for us now that we've been using this normal model pretty much all the time. So first thing we looked at with normal models were z-scores. Z-scores are really nice because they allow us to compare data that's otherwise very difficult to compare. So I might say that I'm kicking a soccer ball 100 feet and Dougie's throwing a football 100 feet. What is, more impressive? Well, throwing a football, kicking a soccer ball, very different. So finding z-scores for those would put them into standard deviations, making them a little bit easier to compare. Okay, that formula for z-scores tells us to take our individual data, subtract the mean, and then divide by standard deviation. So I would write that as x, that's my individual. I'm subtracting the average, you could call that x bar or mu, and then we'll divide by the standard deviation, which I'm just going to call s. Remember that a z-score is always measured in standard deviations, so if I get a z-score of, let's say, 1.4, this means that I am 1.4 standard deviations above average. I know it's above because it's positive. Okay, oftentimes they're going to give you this notation here, n and then mu, comma, sigma. This is a great way of showing you that this is the normal model. Here's the mean, here's the standard deviation. So for example, they might give you in a problem just n, let's do 250 with 50. And this might be for SAT scores on the math section. I could say that the SAT scores are normally distributed. You have to know that this first one is the average and the standard deviation is 50. Other times they're just going to give you a picture, so they might draw that normal model. I would have my average labeled or my mean labeled at 250 and my standard deviation of 50. Okay, the 68, 95, 99.7 rule tells us how much data we have falling within certain standard deviations. So I'm going to draw just a quick picture here for that. I'm going to make my normal model. I'm going to label my mean at 0. And we've learned that most of our data falls within 3 standard deviations. So I'm going to go 3 standard deviations above and 3 standard deviations below. The 68, 95, 99.7 rule says that 68% of your data falls within the first standard deviation above and below. So this would be 68%. 95% of your data falls within 2 standard deviations above and below. And then almost all of your data, 99.7%, falls within those 3 standard deviations. So remember, if you get a z-score of something that's greater than 3 or less than -3, that is considered to be quite abnormal, quite unique. There's 2 main calculator functions that you want to know pertaining to that normal model. The first one is finding a z-score on your calculator, so we would use normal CDF here. So normal CDF is going to be under our distribution, so I'm going to go to second vars, normal CDF. I'm going to type in my lower and upper bound, so let me just give you a quick example here. Let's say I'm starting at, I'm just going to use 0 and 1. I want to start at 2 and go to the right. So my lower bound in this case would be 2, upper bound is 100 or 1,000, something large. And this gives me the area of 0.0228. Now I thought this was opposite, and this is wrong. If you're finding z-scores, if you're using normal CDF, this is actually finding the percentage, and this is finding z-score. Go ahead and switch those for me, guys. Sorry about that. If we're using inverse norm, the question's going to be in the opposite direction. So maybe I tell you that this right here, instead of this like 2%, maybe this is, let's say 3%. And we want to find what this z-score is. If we're searching for that z-score, we're going to use inverse norm. So second bars, inverse norm. The area, if you have an older calculator like mine, this area is only the area on the left-hand side. So I don't want to type in 0.03. I actually want to do 0.97 since there's 97% on this left. If you have a newer calculator, you might be able to select right, center, or left, in which case you can pick this right-hand side and type in 0.03. Once I calculate, it gives me a z-score, so I know that this z would be 1.88.